Hi, I'm Alan Ross, and this is the Grid Resilience and Reliability Power Panel. I'd like to thank our guests. We're going to go through that in just a minute. Uh, there'll be a little bit about me on the screen any second now, and you can see me. That was when I was younger. I probably should update that picture, right? I am the managing editor of APC Media and a partner with my partner, Maren Duganzik. We started this about 5 years ago, and we publish about 9 magazines a year, plus two Women in Power Systems magazines. They are digital and sometimes in print when people want the print versions. But we've been blessed to be able to do a lot of different things in the power industry, and this is one of them. So let me introduce our guests, and they will take just a moment to talk about themselves. First, it's Troy. Troy Cherry, thanks for joining us.
Thanks, Alan. My name is Troy Cherry. I'm the head of business development for Reinhausen Manufacturing, or MR. I work at the head of business development for basically the tap changer division, which is the voltage control that's installed in large transmission and distribution substations.
I noticed too, Troy, that you have an accent. You're from South Georgia, right?
Yeah, exactly.
So
Brisbane, Australia.
Brisbane. And how long you been here?
2007, I come over to the US and based in Atlanta, Georgia. Funny enough.
Okay.
Uh,
Which is where the company is based. So we'll catch up sometime and have lunch. All right.
Sounds good to me.
And you can read there about MR. I've butchered this Maschinenfabrik Reinhausen. Is that right, Troy? Did I get it?
Yeah, that's correct. Internationally, MR, and in the US, actually, we go under Reinhausen Manufacturing.
Excellent. Next up, Seth Johnson. Hey, Seth, you and I have done this before, so we should be old hats at it, right? In fact, we did a one-on-one interview that is on our website. Brilliant interview. Thanks for doing that. But talk a little bit about yourself.
Yeah, thanks, Alan. Happy to be here. Seth Johnson with a company called Powerside. We focus on the niche area of power quality. And so I'm excited to discuss today on how that impacts grid reliability and grid resilience. I am the president and general manager for our corrections business division, which is headquartered out of Montreal, Quebec, which I am here at our Montreal facility today.
Excellent. There's a recent report out. I wish I had it in front of me, but it was from the Department of Energy. And I think they took the data from another, maybe it was EPRI, but the amount of losses from power quality issues in industrial United States has now surpassed $70 billion a year. That's huge. So you all have a great market because things are not getting better; they're getting worse, and it's having a great impact. We'll talk about that a little bit. And next we have Ken Peterson. Ken, you and I have also done this together, haven't we?
Yes, sir. So thank you for inviting me today. And yeah, I'm currently with LUMA down here in Puerto Rico as the director of our substations group. So I started our large project substation group, which is a construction commissioning team and supporting internal resources. But recently I've been supporting our capital projects as well. So setting up a lot of our long-term goals for some of the bigger construction jobs that we'll be doing within the substations down here in Puerto Rico. And been doing this for a minute throughout the years as a contractor as well. So it's a privilege to be down here and be a part of the rebuild and reorganization of our Puerto Rico grid.
Yeah.
So
it's interesting. Each of you has, and there you can see LUMA, which is it's a quanta technology or quanta services.
yeah, Quanta Services and aligned with ATCO out of Canada. So we are combined, and I'm obviously from the Quanta Services branch. And our corporate headquarters in Houston, Texas.
It's interesting. You're in Puerto Rico. You're coming into the next hurricane season again. Troy, you've got MR growing tremendously in the United States with service capability, not just manufacturing. There's a lot going on there to update the grid. So grid resilience and reliability, MR is heavily involved in it. Reinhausen tap changers are probably ubiquitous. If I don't know how much market share you got, but I don't see anything but Reinhausen tap
Right.
changes out there, right? And Seth, I just said, we've got $70 billion of power. I mean, and that's industrial America. That wasn't utilities. That was just industrial America. So the three of you are all heavily involved in grid resilience and reliability, which is brilliant. Uh, we're going to do kind of a round robin on this. So whoever I start with, get ready because you'll be the first up, and then you'll be last the next time. So the first question I've got is, if you were to explain to me, I was not a grid expert, okay, but you were explaining to me when I say grid resilience, Ken, I'm going to start with you. What does that mean, grid resilience?
Well, yeah, to keep it simple, won't go into the public safety and all that, but just think of it in simple terms. I thought about it for a minute, and I related it more of training, right? So for a marathon, I am a runner, so I put it in that perspective and thinking about continue to make sure the body is ready, right, for the long challenge. So let's think about the resilience in that fact. You mentioned the hurricane season. I'm actually going through some of our FEMA training now to be part of the incident command center upcoming next month during our season. So yeah, those are part of the processes of resilience, right? To make sure that we are ready to respond for an incident, whether it's natural disaster or a threat, right? It could be cybersecurity as well. So being prepared as a marathon runner, continuing to train and make sure the body can handle that long duration, right? And then of course the recovery, right, method. My body, right? If I train enough and I don't just show up on the day of the race thinking I'm gonna survive this challenge, then I'm better to respond and be ready for the next race. So kind of that scenario, looking at resiliency as a personal perspective as well.
Isn't it a little bit like you're a marathon runner, and it's fine, you got to train, you got 26.1 miles or whatever. Here's the deal though, along the way, you're going to be attacked and you don't know
That's
where,
right.
you don't know when, but there are going to be surprise attacks on you as you go the 26 miles. It's not an easy run, right? Anyway,
No, yeah, the body will react to differently depending on how hard it trained.
yes. So Seth, same question to you. Any difference, or what's your analogy?
Yeah, for me, I mean, grid resilience is really, the ability to withstand and recover from events. With that, there has to be an incredible amount of infrastructure in place to be able to recover from these events. And to do so, this could be automatically, there could be some, manual interference there that needs to be done to be able to recover. But I kind of like to think of it as, we all use computers in our daily lives, right? I personally use a PC, and from time to time, I'll get a notification on the PC that, Windows has stopped working, and please wait for a response or close the program. And right at the time you're about to close the program, it starts responding again, right? So for me, that's an easy example of what resilience is, right? It's recovered itself. It's now moving forward and it's working again, right? So for me, resilience is all about recovery, and as Ken mentioned, there's many aspects to that, right? I mean, you could go down the safety rabbit hole, of course, and many other aspects of it, but to build a resilient grid, you need a significant amount of infrastructure and data and information, and to be able to do that, you need to have the ability to understand what it is that you're looking for and what these events are that are occurring. For instance, if it's a event like a tree that goes onto a power line, right? Maybe a recloser trips, or power comes back on automatically, right? That's an automatic situation that occurs. It's resilient. It's recovered on its own. So that's how I see it.
Excellent. Auto recovery. All right, Troy, same question. You get to go last so you can like pick up on anybody else's or say whatever you want.
Well, my background's actually substation automation and protection, so I'm right down the same chain of thought as Seth. I think it's the ability to ride through an event with limited impact on the service area or service territory, right? When I first come to the US in 2007, these events were typically around summer peaks, winter peaks, and polar vortexes and demand, right? And funny enough, the Reinhausen tap changes is what would be used to tap down the transmission substation voltage to minimize the impact of these peaks and reduce some demand. And then the other option was to start, cutting out customers in order to avoid a larger wide scale outage. Now, when we look at it 15 years later, we're looking at wildfires, hurricanes, tornadoes, cyber threats, domestic terrorism events, these kinds of things. So it's changed a lot, and as Seth mentioned, there's a significant amount of infrastructure that needs to be invested in to be able to increase the resiliency. And the frequency and the severity of these weather events are increasing, and also affecting larger regions where utilities may not have been experiencing before. So now you bring into this kind of concept of utilities that haven't been exposed to these kinds of events, now having to consider, the restoration and resiliency kind of methodologies. And I think the important part is both mentioned from a resiliency perspective is also the ability for restorations. That's also added in the IIJA funding now. So there's actually a place called out for resiliency and restoration. And utilities are doing the investments like automation, storm hardening, covered conductor, undergrounding like this. But that really doesn't help our restoration efforts, and we really got to think probably more closely on the actual topologies and the ability to enable the topologies to have the restoration capabilities. So that's how I kind of see that from an operational and a topology perspective for the grid. Yeah.
Okay, excellent. It's interesting. Two pictures come to mind recently. One, to your point, Troy. One was Houston, just the recent where you see these huge transmission towers down. I mean, that's not an easy fix.
Mhm.
There's a couple of easy fixes that happen when you have outages like that. That is a long-term fix. It's just striking. And I think, Ken, not this last hurricane, but the one before that, same thing happened in Puerto Rico. There were transmission in the mountains. I mean, it's not an easy fix when the towers are down and their access is just a lot more difficult. So you've got these problems now that restoration is going to take longer and be more difficult than something that simple automation can fix, right? So that's a great one. We'll talk more about restoration. I retired as the president of the Electric Power Reliability Alliance, an organization that I helped form. I loved it. That was the best work I ever did in my career, and it was the last thing I did. I'm still doing this, but as a professional, full time. Reliability. I'm a certified reliability leader. I'm a certified CMRP, certified maintenance and reliability professional. So I got some reliability background. Most of it, though, is non-utility grade. Talk to me about reliability. Define it in the same way. Seth, you're going to go first.
Fantastic. So, reliability to me is really, the capacity to avoid disruption at the end of the day, right? Is power on or is it off? And, in many cases, there's areas around the world where they don't even have sophisticated enough metering or smart metering to know whether or not power is on or off, right? So I see Kenneth smiling over there. So obviously he's got experience with that. So it relies on, a phone call. Oh, my power's out. Something's going on here, right? I look at the reliability metrics of U.S. distribution systems, which is, published data. And one of the things that that you see, while it's not significant, the frequency and the duration of power interruptions has increased over time. And there may be many factors to that. One of them, of course, being higher penetration of renewables, so inverter-based resources. So, obviously the way we're generating power has changed. And then the other thing, of course, which I think we'll discuss later, would be things like, climate change and, weather-related activities. So, for me, at the end of the day, reliability is the ability to avoid disruption. The question is, what is it that creates and causes power distribution or power utility power grid to not be reliable? And that's really where there has to be a lot of thought involved in there, because there's so many factors that go into whether or not power is on or off. It may be as simple as a blown fuse or an issue with the conductor, but it could be much more challenging than that as well.
Yeah, good answer. Good answer. Next, Troy, your answer. Reliability.
Yeah, exactly, Seth. I think those metrics we talk about, like SAIDI, SAIFI, KD, MAFI. I mean, they've been reported to the commissions and to stakeholders of utilities for decades. When I first started coming into the US, I was actually doing recloses, and we'd just look at increasing the reliability metrics by adding recloses, splitting feeders, getting down 1,800, 500 customers per protection zone, right? And like you lose a fuse, you got to send a crew out. A recloser can trip, remove those transient faults. So a lot of that was reducing outages because of transient faults, right?
Yeah.
But having said that, a radial feeder is only as reliable as its feeder head fault or midpoint fault, right? You're going to lose that whole feeder on a sustained outage. So that's, once again, when the topology comes up and you need to add tie points, additional feeds, auto changeover schemes, adding control and visibility to the system to just increase overall reliability. And, I think you can have a reliable system, like most of the US here would probably say we're pretty reliable, but are we resilient? That's another question, right? So there is a significant investment that needs to be, added to that general reliability metric or quality of reliability to be resilient.
Excellent. So he used the word topology, Ken. You've got a topology issue down there in Puerto Rico, but before you get to something like that, talk a little bit about reliability of the grid. You've had a great deal of experience in this area.
Yeah, so yeah, and obviously it goes heavy into the distribution, which we're all hitting that topic. I mean, the transmission is important to get our substations, but having the reliability out on our distribution is our, if you will, our low-hanging fruit, right? And some of the mentioning of the smart meters, I smiled because that's our big initiative that we're kicking off right now. When we first took over, it was the phone call, and so just those little things, the simple things that we can think of, most of the time we take advantage of. Some it's a different methodology when you're, we were excited when we got WhatsApp to get it notified instead of the phone call, right? But it's baby steps, and then having the resilience goals kick back into the reliability of our distribution is a key thing. But I also, you hit it, having the ties and the feeders, I think that's a great model to think of it. I took a minute and thought about the example of the airplane, right? So if one of my old CEOs had his own pilot license, so we got into this. He was really proud of also an engineer as his airplane. He had upgraded the controls, and they also had, we had twin engine, right? So think of it that way, right? If you're up in there, and he says, Ken, redundancy is our friend, right? We're engineers, and says if I have a problem with my one single engine here, I got my redundancy, and I can click over, and I'm not going to lose my reliability, right? We're gonna land safely to wherever we take it. So it's the same little concept there for the simplistic model, to think of it in that methodology, to just say, hey, if I have that extra tie-in, or have a another feed out of the other station, right? And I only sectionalize this portion of it. I only have the set amount of customers versus, the whole 8,000 on this line or whatever the count is. And that's, when we look at the duration and the time, right? When we try to talked about this, the matrix, but yeah, reducing those is obviously the key of what we're trying to do. So if we have our redundancy, then I know that's some of the goals that we're working on down here, and a lot of the different US models as well.
There's an interesting thing too. If you think about it, if utilities have 50 state regulators in the United States and 10 in Canada. So you've got this regulatory body that pretty much gives rate increases to what? Asset purchases, right? And they're not really giving rate increases to a lot of the things that we need to do that are not buying big transformers or generators. And that's part of the problem in the 50 states, is educating the marketplace as to what it's going to take to be redundant and resilient. I love you do these analogies, Ken. So now we got one that is the marathon runner, now the airplane. I don't know if any of you all might be too young. You might remember back in the day, some of our airplanes had 3 pilots and 4 engines, and then 3 pilots and 3 engines. Now they pretty much all have 2 pilots, and I'm talking about jet travel. They have 2 pilots and 2 engines, and we are more reliable with 2 pilots and 2 engines. And it was a big thing when we went to 2 pilots. Is, oh my God, what are you going to do if you only have 2? And then we went to 2 engines. Oh my God, what are you going to do if you only have 2? But today, that becomes the norm for us because of the quality of the pilots and because of the quality of the planes. We don't really have a problem with it. So without naming names, unless you can name names, you've all had some experiences with when the grid wasn't reliable and or resilient. And in your careers, just do me a favor and talk me through an example or two. And if you want to have some discussion about it, please just break in after somebody shares and then share yourself. And Troy, you get to get picked on first on this one. Issues where the grid was not reliable or redundant that you can point to. There are specific examples. They're not the airplane thing that Ken's talking about. They're not the marathon. They're the grid.
Yeah, well, I mean, right in my neighborhood, we've had 2 hurricanes in the last 7 years, well, Irma and Ian, and I personally have been out of power for 5 and 7 days. So it's interesting. We talk about the resiliency part, but really when we have these events, how resilient can we really be when this hurricane hits in certain areas of the state where you can't avoid it, right? The biggest challenge, I think, for the utilities is having this centralized generation and this transmission network, right? Where this is the core of getting the electricity from the generation to the customer, right? So we'll see, and we saw the big Texas issue with that was demand thing, right? So it can be any kind of event, but really the transmission part is the backbone of getting the power from the generation to the customers. And we'll actually see, I think, DERs coming online, distributed energy resources, and potentially microgrids coming in to be able to isolate those sections of the network so the repairs can be done, and then we can have local generation and local power to the areas where that haven't been affected. You'll also see what's interesting in Southern Company. I lived in Atlanta for quite a long time. Is a lot of their new solar power is coming in the south, where they've got cheap land and lots of available space to do it. But a lot of their growth is in the North Georgia part, right? So now you've got the people, the growth, right, and the need for the power not matched up to where the available alternative resources are coming from, right? So now you've got central generation and then regional generation, but not exactly where you need it, right? So it's kind of an interesting dilemma for both the resiliency and restoration sides of this.
Yeah, your point about distributed generation, the distributed DER and DERM, the management of that is it kind of exacerbates any sort of event that you have, because it could, again, we go to Houston and there were wind turbines just completely knocked down, and that generation that you depend on suddenly is gone. So it's a weird time. I love microgrids, by the way. We're going to come back to that. Got a question about microgrids, how they can actually help in situations like this. Next up on this one, Ken, is you. Any situations? I can't talk about Puerto Rico. We all know about that, unless you want to talk about Puerto Rico.
Yeah, well, obviously it's the longest in history of U.S. modern history, 6 months from Maria, but I wasn't here, so I can't speak to it specifically. But yeah, I've heard some of the stories of the locals that were walking through it. So it's when it really does go deep into your heart when you listen to what they lived through. I heard a gentleman saying, I went through 2 generators. I think it was a 3,500 watt generator to keep his house up, and the cost was $6,000, in fuel for 6 months. So you think about your electric bill that you complain about, right? Well, start using gasoline to power up your house for 6 months because you don't have power. That's a huge difference.
Mhm.
But and I also think about, I was at a Doble user conference in San Diego a year after the big blackout down there in 2011. So that was a cascade effect as well. But it's both a big event that happened because there was not enough planning, and some of the local utilities attached to each other started in Arizona and then ended up in complete blackout for San Diego. But it also is a testimony because we got to hear it from their leaders, about they actually had a plan. So in real time, right? They had simulated it, but to get that generation, that's what we talked about. Having their generation separated, was both something they thought would not happen, and when you had all the cascade effects of the generators, and then taking out San Onofre nuclear, and then dropping out everything else that was overloaded after that. So that's definitely was a great example. And then just like you said, just the recent event. My wife was in Houston, and I was down here in Puerto Rico with the storm that went through a few weeks ago. But yeah, seeing the pictures of that transmission line crumbled down, right? And it's I know we're going to get to that in a minute as well, but just the newer events, like you said, that not understanding that normal events that haven't happened, and that are happening recently, or longer or more frequent. Being we are seeing preparations being made, but how do you prepare for the unknown? Well, you got to have a plan. So we're seeing a lot more of that as the case, like I said, even back in 2012 of San Diego blackout. They without a plan, it would have been a lot longer. And then the recent one here in Puerto Rico, I think, is a testimony too. Seeing Fiona recovery as a lot shorter than what we had, could have been a lot worse, right? But just showing lessons learned, I guess, if you will, that from past bad reliability and bad resilience scenarios, and then walking through that and making sure we understand, and we make new goals and new objectives. So I don't know, that's obviously real time, and then all of a sudden working into what we're doing different, I guess, is kind of combined there. Sorry.
Okay. Seth, same question. Share some bad things that have happened. Ken got to talk about Puerto Rico then and Puerto Rico now because they have, LUMA has, you inherited a very tough situation, Ken. So kudos to you guys for making it more reliable and resilient, and you still have in the next hurricane season to get through. Seth, sorry, go ahead.
Yeah, so I'm gonna talk about an example of something that happened kind of more on the grid edge. So obviously there's a lot of hype about the electrification of mobility, right? So EV charging, particularly level 3 DC fast charging, and the power consumption that's related to that. Well, we had a case with a utility on the west coast of the U.S. where there was a fairly large EV charging station that got put in. And one of the things that was unique about this EV charging station was that it was actually relatively in a relatively remote area, and there was a significant amount of adjacent solar power generation nearby. Okay, so you have this distribution grid, right, which is distributing power to many different folks. You have a very heavy load being the EV charging station, and then you have power generation happening very close at a very large rate with solar. And we got called in because during peak solar output times, so during the heat of the day when the sun was very strong, they were having issues with the DC fast chargers, and they could only run them at about 50% capacity. They would actually trip off. And one of the things that regulators have done is they've put a lot of requirements in there in terms of you need to meet these standards if you're connecting this type of load to our grid. You need to meet these other standards if you're generating power to our grid. Well, it's kind of a loose area. Not everybody's following those requirements, and not all utilities or power providers have the ability to know whether or not somebody is meeting those requirements. And so us, being focused in power quality, we went and looked at this facility. We did some measurements and some analysis on what was happening. And what we actually were able to determine was that the level of harmonic distortion coming from the power generation and from the significant load was way outside of compliance, essentially. So, these the charging infrastructure operator was upset because they were having to tow away vehicles actually from here, okay, because they couldn't charge them, right? And the issue wasn't the load itself, it wasn't the power generation source adjacently itself, it was them both working at the same time as a combination, right? And so this basically created a level of harmonic distortion, or I guess, quote unquote, dirty power up onto the utility distribution side that was so significant that certain loads would not operate, certain power electronic loads would not operate. And I think, again, this is kind of a very unusual, very random case, but it really speaks to the importance of having visibility on what's going on, because yeah, we can have all of these standards for power generation and power consumption and interconnection requirements and all of this, but who's managing and regulating that to make sure that we're actually meeting those standards? And the truth is you put it on the engineering firm to do that, you might put it on the utility to confirm it, but once it's set in stone, oftentimes there's no going back to seeing how it's actually operating until, of course, there's a problem like this one.
It's interesting. I'm in California now, and my son has solar on his roof, as do a lot of people in the neighborhood. But there are so many problems with the contractors who did not meet compliance. They didn't do, it was just like the Wild West. Now there's a little bit better control, but the utility here, Southern Cal Edison, had to all of a sudden adapt to a lot of, as I said, the Wild West. That's the second thing. The other one, he's got an electric car, an EV. And I'm not used to driving an EV in terms of watching that gas gauge go down, right? So here I am. I'm at the trickle charger he's got up there because of the doggone solar thing. I mean, it has been a nightmare. So what do? I go to a Tesla supercharger. It's not a Tesla that he owns. I go to a Tesla supercharger, and the thing I've got doesn't work with the thing they got. It's like, it's just crazy. And I'm thinking, oh my gosh, I got to get back because I got to trickle charge it. Guess what we did next? We got in the old Honda CRV, CRV gas thing. And that's what we use now to drive around. And it's funny. Okay, I want to go to something. Now we've talked about the problems, the definitions. Let's talk about what the industry needs to do. What is happening out there that if I were used to be ratepayer and then I became a consumer and now I may be a prosumer, someone who's actually involved in it, and the general public. You talked about public safety just briefly, Ken. You mentioned that. I think Seth or Troy, you talked about safety, and there's a lot going on there, but what does the industry, you think, still need to do or to continue to do to create a more reliable and resilient grid? And you're not allowed to say hire you. Okay, that's not the answer. It's got to be a different answer. Anyway, I'm going to let Ken start on this one. What do we need to do as an industry?
Oh, and Seth brought up well, both of you were just talking about, the whole EV, and I used to live in California too, and that was uh, one of my bigger contracts is actually working with some of the utilities down there doing the EV. So, what you brought it up, the capacity, right? So, I know that it's that race again. It was the solar race to see who can get it up on the house first and get those contracts. And I saw it there, and California's kind of leading the way on the electrification as far as going into that, and balancing that. And that's definitely it's been a topic. I haven't been connected to it for a year, but that was a lot of the going back. And when you see a utility grade installation versus a contract, because I worked with both, and like you said, the contractors showing up to try to get the low hanging fruit because it's a new demand to get EV stations. Like Alan mentioned, the difference. You go to and see the line of Teslas, and they only have 6 chargers instead of 12 or whatever. What are we waiting for the next capacity? And updating, our distribution to make sure that they can handle that capacity. And I know that I've looked at, a lot of the grid edge, some of the things that are being discussed, having the shared, resource within the neighborhood. I got to tour not too long ago. Duke Energy had the DC house, right? And the whole concept, everything was on DC, and you had your Ford Lightning that back feeds both ways as a source, and then your battery source and your solar, and then transferring it in between the houses, having a shared resource. But how do we look at that as a future microgrid, to help with the reliability and redundancy? I think there's a lot of talks around it. But then again, we also look at the socio-economics of it, right? Not everybody can afford a Ford Lightning, a battery pack, nice high, not the trickle charger, right? And solar or whatever the combination looks like, right? Not everybody has the funding to that. So do we, is that a supplement to rate case? Does it go back to, our U.S. model of where we're going? So those are some of definitely the interesting topics that are going around out there, and I know it's going to make it an impact when we can have the I guess, if you will, the meter feeding both ways, right? And helping out. I know there's a lot of regulations that have to be more looked at. Down here we've definitely had a lot of solar that's been added here to help subsidize it, because we have a capacity problem as well when we get into generation. But I think that's also what we're going to see, right? As the loads increase, everybody wants to plug in their vehicle at night. And I know there's a lot of creativity around battery storage to supplement that load after the solar turns off and the lights go out, right? So those are definitely some of the things that I know are the hot topics, and it's going to be interesting to see, all of and I have my young son that's going through engineering school now, so I'll say, well, here, make sure pass the baton on. And I think that's also keeping the generation. And that's another. I know Alan and I have talked about that in the past in a few other interviews, but having the the industry keeping the excitement at the younger age. And there's a lot of new technology out there that does interest. That's one thing that I get to work with is a lot of intern engineers down here, and just to see the enthusiasm that they here's somebody that's been in the industry for a minute, and they just start quizzing you, and having that inquisitive mind and making sure that we are introducing the industry to could be even sooner, right, all the way down to the high school level. Doesn't it?
Yeah.
Not everybody wants to say, hey, I'm going to go do said thing with my hands, but there's also a lot of research and development that needs to be a part of our future technology that I've kind of touched on. So I think that's enough out of me. I'll listen to my fellow panelists.
Technology will save us, right, Seth? Same question for you. I'm not sure technology will save us, but
Yeah, well, I think, we've got to be careful on fast deployment of new technologies, right, that haven't been fully tested. That's one of the reasons why, I mean, Alan, you brought it up, solar out in California, right? It's like, hey, nobody's testing these inverters. They don't know where they're coming from, and everyone's just putting them on, right? We're getting more and more sophisticated with that. But to be honest, early on when we were doing this, it wasn't really a big deal because the percentage of penetration for something like solar, let's say, was so low that the impact that it could have on the grid was very minimal, especially when you look at it from a residential standpoint. So, I think making sure that we put in the right processes and procedures to quantify and qualify different types of emerging technologies that are going onto the grid. A lot of what we're doing and what we're seeing for the future of our resilience and reliability of the grid is going to be driven by power electronics or electronics components, right? Well, there's a few things I know about electronics is that they're kind of like human beings, actually. They don't like being really hot, they don't like being really cold, and they don't like being dirty. So, I mean, it's kind of, you've got those three things there. And so, as we continue to put more and more power electronics and, electronically driven components onto the grid, they need to be able to withstand what is going to be, the extreme temperature swings that we're seeing, from a hot side as well as the cold side, and then also being able to be designed to be put out in the elements is another thing to consider. So, we need to be very diligent on moving quickly to be able to get new technology out there, but we can't just put technology out there that's going to fail or cause problems, because then we go through the same cycle over again to try to fix those issues.
excellent. Yeah, technology will save us. Yeah, right. If the technology is right. And if the technology, you hit a good point. For the whole grid to be resilient and reliable, every component of the grid has to be. And so when one component fails, that's the weak link. And we're adding a lot of technology, as you say, and in the solar world, inverters are king. We're now moving almost to more DC out there than we've ever had before, and it requires technology to adjust. The grid's got to adjust to a lot of things. So I think utilities are doing an amazing job adapting and taking in DER and management of everything, and then taking into account the weather situations that they face there. But Troy, I want to give you the last opportunity on this. What's going to save us?
Yeah, there's a lot to unpack, and I appreciate the responses from, I think I mentioned earlier that the severity and the frequency of these weather events are increasing, right? And now it's reaching different regions that utilities, probably hadn't been prepared for or budgeted for, and now they're looking at, resiliency and restoration measures. Most utilities have included like storm hardening, undergrounding, fire mitigation measures in their IRPs or IDPs, right? Their integrated resource plans or distribution plans for the 5 or 10 years, but I think when we look at, the old pillars of safe, reliable, and affordable power, right? Then we start adding safe, reliable, resilient, affordable power. It gets to be very difficult to keep that, power affordable, because these utilities are really pouring in a lot of money in the undergrounding, the covered conductors for these kinds of events that we're trying to be resilient for. And then I also think a little bit what Ken mentioned, like we look at in the U.S. there's 1,800 utilities, and 1,200 of those utilities are under 100,000 meters. Some 10,000, 15,000 meters. So we look at the technology that they can actually deploy and afford, compared to an IOU, then you're really looking at a really challenging environment for like munis and co-ops, in Indiana and South Carolina, in Arkansas and Oklahoma, Iowa, all these kinds of places. So, it's just a really diverse country with a lot of utilities to manage, and then it comes down to resources, from a labor perspective and a skilled workforce perspective, and then just what's interesting is when we talk about adding EV charging and bidirectional power flows on the edge of the grid, we really start to look at our distribution transformers, which we ran to failure for a long time, now actually having impact on people's livelihoods, because they do need to charge their EV and they do need to do these things to get to work and to be productive through society, right? So we bring in a lot of challenges, and I'll agree that we've been pretty good overall in the US adapting to a lot of these challenges fairly quickly from a utility perspective.
Excellent. Good point. Labor, all of it, and Ken alluded to it earlier, and we've talked about it. Labor shortages, that skilled and unskilled labor is going to impact utilities' ability to do it. And you're right, affordable is a big word. Most munis are run by cities, right? There's a council, and that council typically decides what they're going to spend and how they're going to spend. And I think most of the municipalities in the country, and I won't say all, but most, have a tough time getting more money to do the things they need to do. But there is an expectation that you got to keep it reliable and you got to keep it cheap and you got to do all these things. It's very frustrating. The regulatory environment in the United States drives me crazy, because 50 states and then a whole bunch of municipalities, as opposed to in many countries of the world, this is what you do and this is how you do it, right? Anyway, we've kind of run out of time for our discussion, but we've got questions. The first one is a really good one because I'm pretty passionate about this, and anybody can start. What role will flow batteries, and I think they said redox flow batteries, but this should take the thing. Let's call it utility grade flow batteries, or what impact will storage, or should storage have on the reliability and resilience of the grid? I'm going to start with you again, Ken. Storage, because I know you all are thinking about that down in Puerto Rico.
Yeah, so we've got actually doing a couple microgrids on the smaller islands outside of Puerto Rico. So yeah, we combination with battery storage and solar, and then it'll be a diesel generator is the concept. So some of the I guess to answer the question of the impact of reliability or resilience, some of the key things that I actually was a part of prior to coming here was doing the battery storages at the power plants. So utilizing that for black start, right? So seeing that technology at IOU projects with some of the power plants throughout California, right? So they're putting a capacity in big enough to not, it wasn't set up to backfeed the grid, but more to actually do black start. So we talk about in a reliability, resilience, right, recovery, then is you're not waiting for that 230 line to energize to run your pumps and get your generator back up. You actually have the battery storage. And
Oh, we seem to have lost him. So, Seth, same question. We're going to go to you until we see if we can get Ken back. I hope it's not a power outage. I hope it's an illustration of an unreliable or a non-resilient grid. But
Yeah.
anyway, that if it is, Ken, you did a great job. Seth, sorry.
Yeah, no, so, battery energy storage it's great, but there are some limitations. So, and it really kind of depends on where you're at. I'm going to use an example up in Alberta. This year, I think it was, if I'm not mistaken, January 12th of 2024, they actually issued warnings for rolling blackouts because nearly all of the battery energy storage, all of the renewable solar and wind wasn't operating because it was negative 40 degrees Celsius, right? So, you have to look at the impact in the climate conditions of where this type of equipment is going to be installed, right? There's certainly many benefits. But again, the question kind of now comes back to, one of the topics that Troy mentioned and you as well mentioned, Alan, which is microgrids, right? DC microgrids. A lot of the challenges that we have right now is, the old AC to DC conversion or DC back to AC, and then, continuing back and forth, back and forth, back and forth. And so, long term, I mean, I certainly believe we're going to have a lot more, DC microgrids. So we're going to, a lot more DC to DC converters, DC to DC transformers, but it's extremely costly right now, right? Our infrastructure is not built for that. So, to be able to get something like that mass deployed, it's going to be, pretty far down the road. And just from a safety concern, dealing with DC it's a different beast than what we're used to, right? So they certainly have their place, but I think you also have to look at, okay, where does it make sense? I mean, it's kind of the old analogy: are you robbing Peter to pay Paul, and for how long, right? So you're getting the power from somewhere, you're storing it for a while, but then you have to recharge it again, right? Or recharge those batteries, right? And so there's many cases where it makes sense, and then other cases where it may not. And I think environmental conditions right now are some of the biggest challenges that I see, because you get into, like I said, Alberta, January 12th, basically getting ready to do rolling blackouts, letting everyone know to turn off all their appliances and lights because they have zero renewable power coming back onto the grid. The battery energy storage systems aren't working, and they're relying on the traditional coal-fired power to get the job done.
Crazy. Yeah, crazy. That's a good illustration, by the way, of an example when it doesn't work. Because I remember we don't hear a lot about it and Canadian issues, but the Alberta situation was a weather-related major impact, right? Yeah, Troy, anything to add to to this discussion? And Ken, welcome back. Your illustration of a power outage was perfect. We really applaud your ability to black yourself out because you went through a blackout, and that was a great illustration. But Troy, go ahead. Sorry.
Yeah, I think Seth's right. It's very expensive, and it comes down to benefit cost, analysis, right? But some areas you just cannot get a reliable power to. For the reasons I mentioned earlier with the transmission, you can't just put a transmission network straight through downtown Atlanta, right? So there's some challenges you got, and actually when you think about the microgrid, how big is the microgrid going to be? Is it going to be for 150 houses, 3,000 houses? I come back to the topology kind of concept. If you have a substation, a 30 megawatt substation with 10,000 customers, and that substation goes out, you lose all those customers, right? But if you have smaller substations in the 5 to 10 megawatt range, then you might even lose one or two, right? And they can be back up restored with generators, very easily, right? So that resiliency can be totally based on topologies. And then if we do add microgrids to neighborhoods, we don't have right now we don't have the control, right, or the distribution to get that microgrid to those 150 houses or those 3,000 houses. So we're actually working with some utilities right now in areas where microgrids make sense to have a tap changer in the actual microgrid house, so we can feed back and bring on loads. We can isolate and then bring back on loads with our tap changer in the transformer. So there's still regulation to that microgrid as well.
That's excellent. So you just hit the point, because we're coming near the end here. We're unfortunately we're not able to have the time to answer more questions. We will send them to you, and then all those people that have given us a question, we'll make sure you get an answer. However, Troy, you just mentioned something that what MR is doing to help resilience. So you get a minute to be able to do a commercial for MR or Reinhausen.
Okay. Well, I think MR is the core of voltage control at the transmission and the distribution substations. And now we're bringing this control that's normally in a $4 million or $12 million transformer actually to the residential houses and those transformers outside your house, the 50s, the 75s, 75 kVA, 100 kVA, in a very cost-effective manner to allow more PV penetration to come on, to allow the inverters to export 100% of the time instead of tripping off due to high voltages. And then we're also working with the 5 megawatt and 10 megawatt substations in a box to increase the reliability, enclose them in a green box, so now we don't have exposed isolators and conductors for ice, wind, storm, bringing that all into a box with a protection device and a tap changer, and allowing the substation to come on SCADA or automation with a Cat5 cable and a modem, right? So we're really driving this new topology kind of structure and the edge of network, bringing on DERs and reliability for commercial industrial customers as well.
I love it. It's R&R in a box. That should be R&R in a green box.
Very cost effective. Yeah, very cost effective as well.
Seth, same question for Powerside.
Yeah. So I mentioned a little bit earlier, I mean, our niche and our specialty is power quality, and that is what we do. So we manufacture high fidelity Class A power quality monitoring equipment. I talked earlier about the importance of getting data, right? Okay, so gathering data is one thing, but what do you do with that data is another. So we've developed a fairly sophisticated cloud-based platform to be able to allow utility power providers to do fleet management of either specific assets or understanding what's going on primarily on the distribution grid. And then from there, we manufacture correction solutions. So my claim to fame, I should say, is my slogan of detect and correct. That's what we do. That's who Powerside is. We detect the issues, and then we come in with a correction solution. So we do both low and medium voltage power factor correction, harmonic mitigation solutions up to 35 kV class, so primarily distribution class voltages. And then we also do active harmonic filters as well. So this can be both for utility, on the utility side, or customer side of the meter.
All right, Ken, close us out.
Yes, well, obviously, can you guys hear me? There we go. Sorry, It was a technology problem, not a blackout. Anyway, so yeah, obviously we're doing a complete makeover, if you will, a grid modernization down here for PREPA, and so everywhere from substation rebuilds. So one of the big, obviously the fastest low-hanging fruit is a lot of the getting our DAs in. So we got our distribution system, and it's the fastest way to get some more reliability here. And then we're concentrating on a lot of substation rebuilds. And one of the smaller immediate projects as well is digitization of the relays. So we're getting a microprocessor, down here. We have some, but it's still a lot of electromechanical. So getting a little bit more in communication with those, like we talked about. So we'll have a new EMS and SCADA system that's being integrated now, and so we'll have a redundancy as well on our SCADA. So those are the immediate things that we'll see improvements down here. So thanks for having me today.
Guys, thank you so much. You were chosen because your companies, number one, have bring excellence to the resilience and reliability functions of a grid, and you personally provide a lot of great information, and that was obvious from this. But we thank you for joining us on this power panel. This has been an APC Media power panel.
Thanks, Alan.
Thank you.
Thank you.